All right, so the title of today's lesson is Points on the Number Line. We have 3 learning targets. Number 1, I can represent negative numbers on a number line. 2, I can determine or approximate the value of any point on a number line. And 3, I understand what it means for numbers to be opposites. So opposite numbers, and expanding our number lines to have negative numbers. Awesome. So, for our first activity, 2.1, a point on the number line. It says, which of the following numbers could be B? And we have a list of 5 numbers there. So, if we look at this number line, so most number lines, especially the ones that you've seen up to this point, they start at 0, and as you go to the right, the numbers get bigger. We count up. We can see that B is in between 2 and 3. So at this point, why don't you pause the video and go ahead and circle all of the potential numbers that you think B could be. Okay, so I can tell that B is about halfway in between 2 and 3. And I know that 2 and 5/10 is the same thing as 2 1/2. So it can be B because it's halfway between 2 and 3. Right? So B is halfway between 2 and 3, then 2 and 5/10 or 2.5 is a great potential answer. 2/5, so anytime you have a fraction, a normal fraction where the numerator is less than the denominator, you know that that number is less than 1. So 2/5 would be about somewhere over here, so I know that that's not correct. So 5/2 is a fraction as well, but this is an improper fraction. And if I wanted to turn that into a mixed number, 2 fits into 5 2 times, and I would have 1/2 left over. So 5/2 could be B. Because once again, 5/2 is the same thing as 2 1/2 if we converted that improper fraction to a mixed number. 25/10. All right, so once again, that's another fraction. We also know that fractions are division. And if you ever divide a number by a base 10 number, that just means that the decimal place needs to move 1 place over. So 25/10 is actually the same thing as 2 and 5/10, which we already stated is the same thing as 2 1/2. So this could also be B. And 2 and 49/100, that's literally so close to 2 and 5/10, and we can't really tell if that's exactly halfway. It might be 1/100th to the left. So we're going to say that 2.49/2 and 49/100 can be B, because it is so close to 2 and 5/10. Okay. So once again, important takeaway here is that you can represent numbers on a number line in a number of ways. They could be whole numbers, they could be decimals, they could be fractions. And if you need to convert them into a mixed number or whatever to help you visualize, then that's always a good idea. And also importantly, we should just note that a number, if it's in between 2 whole numbers, it's going to be that whole number, and then we have to approximate the distance. So this looks like it's halfway. So 2 and 5/10 or 2 1/2 would be good answers for B. All right, on to our second page for today. Once again, we're going to be talking about temperature. So we've got 5 thermometers here, and the first 4 thermometers show temperatures in Celsius. Write the temperatures in the blanks. Once again, why don't you pause the video here and see if you can complete these problems independently first. All right. So, once again, a thermometer. It's got mercury in it. That's the red stuff. And however high it rises, that's the temperature. And so I can see that this one goes above all the negative temperatures, 0, and it stops right at 1. So this would be 1 degree Celsius. All right. So letter B. Sorry for that weird little cut. I had to pause the video for a second. So once again, A was 1 degree Celsius. Now looking at B, so I can see here's 0 degrees, and the temperature's below that. So here's 1 degree below 0, negative 2 degrees below 0, so negative 2. Third one looks like it's in between 3 and 4. It looks like it's halfway in between 3 and 4. So there's 2 ways to represent that. I'm going to do the decimal way and say that that is 3 and 5/10. D looks like it is between 0 and negative 1. Looks like it's halfway in between. So halfway, so it's not 1 degree below 0. It looks like it's negative 1/2 degree below 0. Not all the way to negative 1. Looks like it's halfway. Okay, so that's one thing that's important to note. That when you're working with negatives, you're kind of counting that distance away from 0. So now here, to fill out E, we need to kind of understand what the intervals are. So how much space is in between each number. So if this is 10 blank blank 25, 10, 15, 20, 25. So that means it's probably counting by 5s. So then this would be 15, this would be 20, 10, 15, 20, 25. All right, that works. So then this would be 5, this would be 0. 5 degrees below 0 is negative 5. 5 more below 0 is negative 10. 5 more below is negative 15. And then negative 20 is where it is at. Okay. So, number 2, Elena says that the thermometer shown here reads negative 2.5 degrees Celsius because the line of the liquid is above negative 2 degrees Celsius. Jada says that it is negative 1.5 degrees Celsius. Do you agree with either one of them? Explain. So why don't you pause the video and try and think about it yourself and write your own explanation. So, once again, a good way of thinking about negatives, count negatives by thinking about their distance from 0. So this is 1 degree below 0. Here's 2 degrees below 0. Is this 2 degrees below 0? No, not quite. It looks like it's in between negative 1 and negative 2. So this is actually the right answer. So Jada is right. Negative 1.5 degrees Celsius. Because the temperature is between negative 1 and negative 2. So if negative 1.5 is between negative 1 and negative 2, then negative 2.5 would be right here, in between negative 2 and negative 3. All right, one morning the temperature in Phoenix, Arizona was 8 degrees Celsius, and the temperature in Portland, Maine was 12 degrees cooler. What was the temperature in Portland? So, it might help to draw a number line. I don't have a ruler on me. Should always have a ruler. So I'm going to draw a number line with a straight edge. Alright, so let's say here is the 8 degrees in Arizona, and here will be 0. Alright, so here's a good way of visualizing it. So here's my 8 degrees, and it was 12 degrees cooler. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is -1, -2, -3, -4. So this is -4 is 12 steps down from 8. So it would be -4 degrees in Portland. So using a number line when you're first working with negatives can be super helpful because you can actually count the steps. So once again, 12 degrees cooler is 12 steps back on the number line, -4. And if you wanted to do, if you can do it in your head, it is just true that 8 minus 12 is -4.